Glad I saw that. Okay. So next question here. Does the word, oh, I said work, I meant the word extreme sound like a positive or negative? So how do you feel about the word extreme? Does that sound like a positive, or does it sound like maybe something you'd want to avoid? So it looks like we've got kind of a range. We're split fairly evenly here on this one. It's like a little bit more on the negative side of things. And there's a reason that the word extreme was used, because agile came out and everybody wanted to be agile. So when extreme programming was being formulated, the idea was, let's use a word that management isn't going to think sounds like a good thing. So the people that are actually using it are the people that actually understand what it means. So it looks like most of us have a kind of negative connotation with it. If you have a positive connotation, it's probably because you're thinking of extreme sports or something like that, like the opening picture we had. So here's a question for you. What sport is the most extreme? Tickling. That is a new sport I hadn't heard of. I guess that is an extreme thing. Tickling, paragliding, probably mountain climbing, got a smiley face, skydiving, skeleton. Okay, that's new. Base jumping. So we've got all these extreme sports. These sound like things I'd enjoy watching people do, but not actually do myself. Bungee jumping, I see that in there. And I should have told you, if you want words together, you got to put an underscore between them to keep them together. Okay, so we've got all these things that we think of when we think of extreme sports. I see there's one that's not on here that I found particularly interesting. I'll show you in just a minute. So all these extreme sports, okay. All these things that are extreme, and remember we're going to be talking about extreme programming, and this does somewhat relate. Okay, so all these extreme things. Here's an extreme sport that I would encourage you to look up on Wikipedia. It is extreme ironing. And you try to find the most extreme place you could be and get there with an iron and an ironing board and do some ironing. So this is an interesting thing. You can look it up on Wikipedia here. I think it's, Wikipedia, look up extreme ironing. There's some pictures of it. I think there's actually a calendar out there that you can get. This one looks particularly dangerous. I'm not sure what they've got that plugged into. Maybe it's a gas-powered iron, which probably wouldn't work underwater anyway, but it probably doesn't matter because whatever they're ironing is soap. So extreme ironing, another extreme sport. But like I was saying, the reason that we call these things we're looking at extreme programming is because the idea was to have something of a negative connotation associated with the name. So if people wanted to do extreme programming, they would have to stop and think about what they were actually doing and not just assume that it was a good thing. Now, in this talk, we're not going to necessarily be covering orthodox extreme programming practice. That's not kind of the goal here. What I'm hoping comes out of this talk is you have a good introduction to what extreme programming is, an idea of what it is, an idea of what it includes, but more important than that, I'm hoping we take away an idea of what were the principles behind extreme programming that made it work, that have made it work and made it successful. Because if we can understand the principles behind what they were doing and how they tried things, we may be able to find ways of doing things that we do today in more extreme ways that will make us more successful, even if they aren't some of the practices that you see in extreme programming today. So here's a cartoon. I remember seeing this as a kid. Calvin is asking, how do they know the load limit on bridges, Dad? And his dad says they drive bigger and bigger trucks over the bridge until it breaks. Then they weigh the last truck and rebuild the bridge. And Calvin says, oh, I should have guessed. And his wife says, if you don't know the answer, just tell him you don't know the answer. So here's my version of this cartoon. So how do developers write working software? Well, they write code and then they give it to QA to test. Weeks later, QA comes back with the requirements and they mangle the code to get it to do those things. He says, oh, I should have guessed. If you don't know, why don't you just tell him? But oftentimes, this is actually how we're producing code, as crazy as it sounds. So what we want to look at today is some of the things that came about in XP of looking for ways to make software projects more successful by taking some of the things we do and dialing them up to make them do them in extreme ways, in ways that give us more benefit. And I just had a device kick on over here. Let me turn that off because it's kind of loud and annoying. at the time of the year where the humidifier is still kicking on some and it's distracting. So, okay, so why was extreme programming successful? We're going to be looking at that, and then also looking at what were the thought processes behind extreme programming. And how can we take that approach and use it to improve our organizations? Because a lot of these principles we're going to look at, or a lot of these practices, are very, very powerful in themselves. But if we can harness the principle behind that and improve our organizations in ways that maybe weren't even thought of when extreme programming was being formed, we'll be able to move ourselves forward to adapt to our situation now, which is really what Agile is about. Okay, so extreme programming. Let's look at what the practices are. They're practices like this. So here's an example of a practice. Pair programming is a practice. I'm actually not sure why that slide is here, so let's go to the next slide. Okay, here's the list of practices. We've got pair programming, the planning game, test-driven development, continuous integration, refactoring, small releases, coding standards, collective code ownership, simple design, and systems metaphor. And we're going to look through some of these things. So pair programming is where you've got two people programming the computer at the same time. Planning game is where you kind of get through and you can play planning poker to try to figure out, get everybody a little game to figure out how big this next piece of work we're looking at is going to be. Test-driven development, where we're writing tests first, watching them fail, and then writing code in response to that. Continuous integration, where every time we check in something, it does the full build. Refactoring, where we're making changes as we go to improve the code base. Small releases, the idea of taking something small and delivering it all the way through to production instead of doing really big releases less frequently. Coding standards, where the team gets together and says this is how we want our code to work, and we're all going to keep ourselves accountable to follow these standards in our code. Collective code ownership, everybody can get in and modify and change anything that needs to be changed instead of having to wait for someone else. Simple design, trying to strive for simplicity, and systems metaphor, which we'll talk about a little bit more here in just a minute. So here's a question where you rank these extreme practices by their importance to your team. Lower ranking for items not used or not important. And these can be a little bit annoying to do because you've got to move them up and down. So try to just get the top three in the order that you think that they're important to you, and then don't worry so much about the bottom ones. So rank these extreme programming practices by their importance to your team. And let me post this one more time here for anyone that's joined. You can go to the URL up there for the link, or go in the chat. I just posted it again. So right now it looks like pair programming is at the top, followed by simple design and continuous integration. You got to hit submit at the end. Okay, now we've got pair programming, test-driven development, then continuous integration. And it isn't like one of these is necessarily more important than the others, but teams tend to gravitate to different ones. And depending on your organization, some of these may actually be more important for you in your particular situation. So I find this interesting. The top 3 or 4 tend to be the small releases, pair program, continuous integration, and test-driven development. I think simple design is in there too, and it looks like they're just kind of getting ping-ponged around, but those look like the ones that are usually kind of at the top there. Okay, so this is interesting. And the main reason I like to do things like this where you have to rank it is just trying to get ourselves to think about what are we doing? What am I pushing to the bottom? And is it possible that some of the stuff I'm pushing to the bottom is things that maybe in my particular environment maybe should be more important to us? Okay, how do you move them around? I think you click, there's little arrows, you move them up and down on the side. It's a little bit annoying. I'm not crazy about that UI. Okay, so let's talk about extreme thinking. So the thought process behind extreme programming is something along the lines of saying, well, X is good. We've got something that's good, and we see that we're getting benefit from it. What happens if we dial X all the way up to 11? Now, this thought process in retrospect, a lot of these things like looking at test-driven development. So we might say that our code is good. What's the most extreme way we could test? Well, what if we wrote our test before we even wrote any code? That would be cranking it all the way up to 11. But I want to point out that it's not necessarily a given that you can take anything that's good and crank it all the way to 11 and have good results. For example, drinking water is good. Well, what happens if we drink 100 gallons of water a day? Some of you may know what happens if you drink 100 gallons of water a day. There was a radio station in California that actually found out this when they did a contest where they wanted people to drink as much water as they could to win a Nintendo Wii, and somebody actually died from it. If you get too much water in your system, you basically drown because your body doesn't have the right balance of everything. And the point of this is that just because something is good doesn't necessarily mean that cranking it all the way up to extreme is useful. And so what extreme programming was doing early on was, let's try these things in the most extreme way we possibly can and see what happens. Hopefully no one dies, right? So here's a question for you. This was when I was putting this talk together last night. I got curious about this. So how much water per hour starts to become dangerous? I was talking to a football player with the Green Bay Packers one time, and he was admiring that someone else that was there had a gallon of water at their desk, and saying, that's what I need to do. I need to just drink lots and lots more water. I was like, well, be careful because you can kill yourself. And he had never heard of that before. However, somebody that's actually actively training for football probably can consume quite a bit more water because they're sweating a lot of it out as they go. Okay, so we've got, looks like most of us are, only 2% are saying half a liter an hour would be dangerous. We got a few more for the 1 liter, and then quite a few for 2 liters, 4 liters, and then some down here. So probably the technical answer for a doctor is probably going to be more around the lines of any amount where you're gaining water faster than you're losing it. So please do not take any of this as medical advice, but generally, your kidneys can process about 800 milliliters to a liter of water per hour. If you're going much above that, your body isn't going to be able to get rid of water as fast as you're putting water into it, and that's where you run into trouble and can kill yourself. So 1 liter, if you get much above, for an average human, much above 1 liter of water per hour is going to be dangerous, but it depends on the individual. So don't go out and try this, but that's generally where most humans fall. Okay, so extreme does not necessarily mean good. So let's look at a few of these things. So testing is good, right? What is the most extreme way we could test? Well, what if we were to write our tests before we write our code? That is test-driven development. So another question, code reviews are good. So what's the most extreme way we can do code reviews? Well, what if we do code reviews while we are writing the code? That is pair programming. So we've got all these different practices that were just attempts to take things and say, what would happen if we did this practice in the most extreme way possible? So thinking of pair programming, that actually turns out to be very, very helpful. No matter how good of a coder you are, there are places where 2 sets of eyes can be a lot better on things. I remember I was working with a team, I was coaching a team and helping them write some software, and we had moved through several different, we moved from Subversion to Git at some point. And anyway, I was looking at the code and I saw something. I was like, man, that just doesn't look like the way we want to do things. I should figure out who wrote this, and maybe we should talk through why they did it this way. So I went back and I looked in Git, and it didn't have, it pointed me somewhere else because this code had actually been developed back when we had been in Subversion. So I went back and looked things up and cross-referenced it, and finally came up with a string. I was looking, I was like, that looks kind of familiar. And I finally realized that was my ID on the old Subversion system. So this code I was looking at that I was thinking this person needed some coaching was actually a previous version of me 3 or 4 years prior. And the point of that is that all of us do things that if we look at it, if we have a second pair of eyes on it and look at it, it's like, there would be a better way to do that. That's what pair programming does, is try to make sure that's happening in real time. So in a lot of cases, you end up with something like this, where we've got requirements, development, tests, and then we do our code review. And then if something comes up in the code review, we go back into the development cycle. Let's see. I'm going to mute everybody, just make sure somebody doesn't come on accidentally. Paste that in here again so we've got it. So it moves back into the development cycle. So extreme programming says, well, what if we move this up here? Let's do the code review along with the development. So that's the pair programming, which creates a type of collaboration that can be very, very, very powerful, not just because you're not just getting the code review, but by getting it in real time, you've got twice the intellect coming to bear on the problems, twice the set of experiences that people have. That type of collaboration is what makes pair programming effective. So here's a question for you. What's the key advantage you'd expect to see in pair programming? Would it be fewer bugs, better design, happy programmers, or faster delivery? So the key advantage you'd expect to see. So which one do you think is the most? And these are all things that could be advantages. I've seen some programmers that are very happy to pair program. I've seen other programmers that would prefer not to talk to each other and don't like pair programming. And John, you've got the comment, 3 is better than 2. When you think of pair programming, how could you even do it more extreme? Well, that becomes mob programming, like Woody talked to us on things. So get everybody in the room that can help deliver the feature and deliver the feature. Okay, so we got a range of things, and none of these are necessarily right or wrong. I do find it interesting that we've got quite a few people who are saying faster delivery. A lot of times pair programming is seen as, well, that will slow things down. What's interesting is in actual practice, that's often not the case for a couple reasons. One is that cycle I showed you earlier where you go down and then you do a code review and then you've got to go back to development and you have all this context switching. So it's a lot faster to get it right the first time. The other reason that the other piece that I think we overlook sometimes is that even if pair programming is a little bit slower, but it helps prevent those things, the actual delivery can be faster because you've got 2 people familiar with it. You've got two views being represented. There's a lot less chance that you're going to do something wrong that you have to come back and change before you can actually deliver it. And it's easy for teams to get so focused on how long it takes them to write their line of code, which in pair programming would probably be, might be slower how long it takes to write a line of code, and missing the fact of how long does it take us to deliver the feature, which in pair programming is often a lot faster. Planning game. So here's another practice. So the planning game is usually something where you all sit around, maybe you've got cards and like, okay, how big, what size do you think this is, whether you're using points or hours or whatever, and everybody holds up a card saying, here's how long we think it takes. Yes, and Craig, you got the test first is not really a testing process, it's a design process. You still add more tests after coding for regression. Yes, although I like to think of test-driven development being, it drives the development, so it's the way that you design your code, and you have the very happy side effect of ending up with some regression tests afterwards that could be valuable to you. So the planning game. Well, this almost sounds a little bit like maybe we're shifting stuff to the right instead of shifting to the left. But what the planning game does is it really moves us to the point where we're thinking of things as being just in time. I'm not going to worry about how big this thing is until we've actually decided to do it, and then we'll worry about how big it is. But there's no sense trying to figure out how big it is weeks and weeks and months before it's even on our board that we're going to work on it. So in that way, this becomes a more extreme way of doing things than maybe how it had been when we were dealing with estimates and things like that. Test-driven development. So let's look at another graph here. So requirements, development, manual tests, and automated tests. So I've seen lots of places that kind of go through a cycle like this. Figure out the requirements, they do the development, they manually test it, and then at some point later they create some automated tests to just make sure those things happen. If you've never worked in something like this, congratulations, but this is a very common way that people approach development and automated testing. Okay, so with test-driven development, whoops, I'm hitting the wrong button. Let me go the other way. So test-driven development says, well, what if we actually take this and shift it to the left? And that's what I'm kind of trying to show here is a lot of these things that made XP work are taking things that are valuable and moving them earlier in the development process. So if we move that there and do the automated test first, well, then we can kind of skip this. We may be able to skip this manual test or make it a lot smaller. It doesn't mean that you never have anybody go in and actually use your application. But if we start with the automated test and then do the development, this manual testing looks very, very different and is not nearly it can be focused on very different things. You can get a lot more value from whoever's going through and actually using the application instead of having them do the types of things that computers are really, really good at doing, which is checking all 100 different ways of doing things. TDD process. So TDD looks something like this, saying what's the smallest piece of functionality that would actually be closer to a working system, and then asking ourselves, how do we test that this functionality exists? Now, like John mentioned earlier, this really drives your design, right? So you end up with a loop like this. You write a simple test, you watch it fail, you write some code. Eventually, if you're writing the right code, that test should pass. Then you should pause, and this is the thing that a lot of people miss, and you refactor. You say, I got the test to pass, but did I do anything in here that wasn't really the best way to do it? I've now got a passing test. Maybe I can refactor. Let me put this off into a different method, or I'll change the way that this works because I may have gotten it to work in a very quick and dirty way. Now let's step back, take a breath, and say, is there anything I want to do to make this better? You refactor, you can run your test again, make sure it all works, and then you move on to your next simple tests. When we think of these happen on different levels. So test-driven development happens on a different level. One is the unit tests. Unit sometimes is a little bit misleading. It can make you think more about how your software is, how you've architected your software. I know some people like to refer to them as micro tests. So they're really small, the things that test very small things and run very, very rapidly. I usually like to think of this, the unit level test is thinking about the application from the way that the developer thinks about it, of how all the little pieces work. Integration tests. Integration tests are where you're testing to make sure that the things actually fit together. And then you've got BDD and a bunch of things like that. All of these things are important in trying to drive the development of your application with tests. Now here's something I've seen a lot is we've got lots of people that say they're doing TDD. Usually it's a very small subset that are actually doing test-driven development of some type. Most of the places I see that say they're doing test-driven development aren't actually, they're missing the driven part, right? They're doing testing as part of their development, but they're not using the test to actually drive the development. And some of the benefits that we've seen with extreme programming of test-driven development is that design that comes out of using TDD can be missing. If you just test your stuff afterwards, you miss the benefit of having it actually drive the design. When you're starting out by asking yourself, how do I test this? You necessarily have to figure out ways to decouple it so it can be tested. That decoupling turns out to be very, very beneficial for for the ability to change the application in the future. Not just because you have tests to prove when you change it that it hasn't broken, but also because you now have, since you drove it with tests, you've had to break things up so you can see into individual pieces of it. And that can create very good software design. The other thing that test-driven development gives you is the ability to approach your code more as if you're sketching with a pencil than as you're chiseling it into stone. And this is something a lot of teams that are new to test-driven development or behavior-driven development often miss. That having your test in place, particularly, and I think that's particularly true when you've got test-driven development from the bottom up of how the developer thinks of things, and behavior-driven development from the top down of how the user thinks about things. If you're approaching your code in that way, you end up with an application that takes its steps based on the behavior that the application is going to exhibit. The underlying code can evolve sometimes very dramatically based on the next thing that you need to do. I've been on teams that were using TDD and BDD. They were headed down the path like using Dynamo or something like that. Suddenly hit something or like Dynamo doesn't make sense anymore. Let's do something else. And they completely changed their backend database, just part of the next user story, because they had the test in place that made sure that the behavior of the application remained the same. So that idea of a pencil where you're sketching with something, you draw a line to kind of give you some structure, even if you know you're going to come back and erase it later. If you think about how they used, if you ever had those books where draw a horse and you draw a circle here and a circle here and lines between them, the lines you start out with eventually go away entirely, right? You may even erase some of them, but it's okay because those help you take the steps forward. TDD and BDD help give you the capability to do that and evolve your application with iterative development. We've got other talks where we've gone into this a lot more detail. Let me see. TDD, I see somebody said, TDD gives me the courage to make changes, whether refactoring or adding value. That's a good point. I like how you said that. Continuous integration. So another piece of the, another part of extreme programming is continuous integration, which is just the idea that you've got code, right? You need to sometimes figure out if your code works. You need to build it and run the tests on it and stuff. Continuous integration was an extreme way of doing that, of saying, let's do that every time somebody makes a change. They make a change and check it in, and it runs all these tests on it. For example, a project I worked on was we were doing a rewrite of an application. The old application required, I think it was 6 people, took them 12 weeks to fully regression test the application. So you'd have to build it, get it out there, deploy it, and then they'd go in and spend 12 weeks going through all their scripts to make sure that everything worked. So they only were able to deploy maybe once or twice a year because it was pretty expensive to do that. With continuous integration and with the test-driven development and behavior-driven development, we were able to take everything that they did in those 12 weeks and do it in 30 minutes. So every time this team checks in a change to the code, even if it's a 2-line change, continuous integration kicks off. It builds everything, stands it up, and runs all the tests on it. And they get that feedback that used to take them 12 weeks. They get that feedback in 30 minutes. That is a very, very extreme change from where they had been before. And with the automated testing, it's actually better than they were doing with the user side of things. Very, very extreme. They had to invest in all kinds of things to make that happen. But on the plus side of it, they can make a simple change and deploy it all the way through to production in a matter of hours if they want to. I think their average time is once a week. They have a change go all the way through. That's a very, very extreme change for them, but that's what the principle was behind extreme programming, right? Let's take something that's good, getting feedback. Let's make it extreme. Well, what if we get our feedback in 30 minutes using continuous integration? Whoops, wrong way. So refactoring, another practice of continuous integration, or of extreme programming. And notice a lot of these things kind of build on each other. Like somebody just said in the chat, TDD gives you the courage to be able to refactor. If you just decide we're going to do refactoring, but you haven't invested in test-driven development, you're probably going to run into a lot of issues with it because you're going to be changing things, and it's going to be very hard or expensive to prove that the application still works the way that you expect it to. So here's a question for you on refactoring. When do you usually refactor? Do you do it as you go? The idea, the Boy Scout principle, always leave the campground cleaner than you found it. Or B, a few times a year, so we stop work in order to refactor. C, we refactor when things get so bad we can't move forward. Or D, we don't refactor, we just rewrite systems. And I have seen teams do every single one of these, right? And where you are is just where you happen to be, right? You may not have control on some of these things. Is this in here again? So this is cool. We got 62% saying they refactor as they go. That's a lot higher percentage than I was getting on this slide a few years ago. Of course, it may have to do something with the fact that people self-select. If you're coming to a talk in extreme programming, you may be more likely to be in this camp. Now, these other areas down here, these aren't necessarily bad things. That may just be where your organization is right now. Extreme programming says if we can refactor as we go and that just becomes part of our daily work, we will be happier with our results than if we wait till the end to try to do it. That project I was telling you about being on, there was one situation where we needed, some of the decisions we had made 6 months prior turned out to be wrong in the way that the project was structured. And so we came up with an idea. I remember everybody checked their code in, and I stayed up till like 2 o'clock in the morning doing some dramatic refactoring on this application. You're moving things around, pulling things apart, putting them in different places. Got to 2 o'clock in the morning, ran the tests, and a bunch of stuff failed. It's like, okay, well, that's not going to work. So I didn't check those in. Next day we regrouped, talked a little bit more, came up with a second idea of how to do it. The next week did something similar. Again, 2 o'clock in the morning, torn everything apart, ran all the tests, and everything passed that time. That was only possible, that level of refactoring, just kind of as we discovered thing, was only possible because we had made the investment in the other practices, particularly TDD, to be able to make those changes. And it was the types of changes that a lot of projects I've seen would actually say, we're just going to have to rewrite it if we want to make these changes. Or we're going to be down to 6 to 8 weeks while we try to do that. So a lot of these practices really help enhance each other. Some good comments there. Okay, so if you don't continuously refactor, you end up with something like this, right? Year 1, incur lots of technical debt. Year 2, incur lots of technical debt. Year 3, incur lots of technical debt. Year 4, give up and rewrite everything. Refactoring says we're going to refactor as we go many times in year 1. As we discover stuff, we're going to go ahead and take care of it right then in small batches. And when you're doing these in small batches, it may not even be a matter of saying, I'm going to create a new ticket to do this refactoring. Maybe it makes sense to do that. But a lot of this work just happens as part of whatever story you're working on. We needed to add a new email module. And as we were doing that, we discovered this other thing that we're interacting with would work better if we refactored in this way. So it's just part of the changes that we make. Year 2, refactor. Year 3, refactor. Year 4, keep building cool stuff instead of trying to do a rewrite. But you can't refactor unless you've actually made the investment in your testing. You can't refactor unless you've actually approached your code with the idea of, we're writing this with a pencil and it's going to continue to evolve. And just because something makes a lot of sense to me today doesn't mean it's going to make sense to me tomorrow. So I'm going to approach my code with the humility that it's going to probably need to change as we discover more and as we mature. And that humility part, I think, is a very important piece of software development, of approaching things with the idea, I'm going to invest in tests to prove that this works. Because someday, some decision that I made today will turn out not to have been the best decision. Yes, we got a thing, but that's rework, right? That's an interesting comment. And I think a lot of times we're so focused on not changing a line of code again just because we've touched it, that we lose sight of the fact that we really should be thinking about the behavior of the application, and the code should be very, very malleable behind it. Like, imagine somebody putting up a house. You know, they put up the side walls. You know, they've got all these 2x4s nailed together. Well, at least where I live, they use 2x4s. You may use something else. 2x4s nailed up there. And they have to get another 2x4 to nail up just to hold the wall in place, right? Because if you just set it there, it's going to fall over until you get the other ones. Imagine a carpenter saying, yeah, that support thing, I'm not going to put that up there because I'm going to have to rework it by taking it back out. That would be a complete waste. It's not a waste. It's like saying, I'm not going to build a scaffolding on this building I'm going to work out. I'm going to, I don't know, rock climb it or whatever. Those aren't, it's not wasteful to actually build things that help you get to where you need to be. And if you write code and it lets you deliver something and then you come back and you make changes to make it better, that's not a failure. That's success. Oops, wrong way. Okay, coding standards. So another practice of getting together and saying, how are we going to define our code? Now, some people can take this to extremes, but things like saying, hey, let's decide if we want to use tabs or spaces. Or let's decide if we've got a style guide we want to do, how we're going to break things across lines. Maybe we'll give everybody the ability to, do a keystroke in their IDE, and it will check to format everything the way it is. So when we check things in, we're not just switching formatting back and forth. This also can help with fixing likely bugs. Let's skip through that one. Okay, collective code ownership. Have you ever been, so give me a thumbs up if you've ever been in a situation where you need to change something, but you have to wait until Thursday because Bob's the person that really controls that code, and we don't want to touch Bob's code because it's what Bob touches, and Bob won't be very happy if we touch his code, so we need to wait till Bob's back, and hopefully he's back on Thursday, but he might not be back on Thursday because if he's on vacation now, but if he got sick on vacation, it may be another week before we see him, so we just can't touch this at all because Bob's not here. If you've ever been in a situation, hopefully not quite that dramatic, but like that, you've been in a situation where you're not actually dealing with collective code ownership. So what extreme programming says is that we should all own the code, we should all be comfortable working together and changing the code. If you wrote a line of code and I come in and find a way to make it better, I should be very comfortable, and you should be overjoyed that I found a way to improve the code, and you should be overjoyed when you find ways to improve my code. Now, Bob has to go. This requires a level of trust that some teams just don't have. It's great when you can get to that, but collective code ownership says eventually someone else will need to understand that code. If we take this approach, this really drives the way that people pair program. I was working on one team, and what they did is they'd have a new story. Hey, we're going to do this with Spring Batch. We've got to do this new thing with Spring Batch. We've done a couple things with Spring Batch. New story for doing this thing. We're going to have to use Spring Batch to implement it. So somebody said, oh, I'd like to take that story. Well, the reason they want to take that story is they had never worked on a Spring Batch story before, which sounds like it would be the worst person to work on that story, right? The person with the least amount of experience. But then what they do is they pair up with someone, and someone else would say, I probably got the most experience with this. How about I pair with you, and then you'll be the experience like I am. So that collective code ownership of looking out for each other and trying to find ways that we can work together to make sure that everybody's got full knowledge of how the code works, and full comfort of digging into it and making things happen. That team was very, very effective in the way that they selected for pair programming because they were being driven by the idea of we all need to have collective ownership of this code. Now, here's a few pictures here of places where there wasn't necessarily collective ownership. This person, their job was to install the swings where the work order says, but there was not much ownership here of the actual thing you were trying to deliver. Or here, I like this one. I don't know what's going on there, but evidently there was a rule to put these things down wherever the tire tracks are, and so they were going to follow the rule. Not a lot of collective ownership here. I'm not sure what would actually happen in this situation. If it would derail the train, I'm guessing it probably wouldn't derail the train. It'd probably just take out their pipes and everything. Oh, this one I like, right? No smoking in Arabic. This is an example of a very good... Now, obviously, somebody had written a note. I need you to write on the side of this diesel fuel truck, no smoking in Arabic. And they wrote exactly what they were asked for. But this is not an example of collective ownership where everybody's taking responsibility for things. Here's another one. I'm not sure. I mean, maybe they were putting these together and didn't know the language and somehow it was written down wrong. And then I think this is one of my favorites. This bridge will be closed for one day between October 17th and 28th. You've got to think that somebody that was making the sign was like, this doesn't quite seem right to me. I don't know when. I mean, is the idea that just one of these days, if you try to drive across the bridge, it just won't be there and you'll fall into the water? But I'm assuming, very likely, somebody here had their hands slapped because they tried to actually participate and collaborate on this thing. Like, no, you put on the sign exactly what I write on the sign. This isn't collective ownership. You don't want code that's written like that. Happy birthday, Ashley, spelled with 2 E's. They put on exactly what they were told to put on it. This is not a cake made by someone with collective ownership for making a happy customer. Okay, moving on. System metaphor. So here's how most projects evolve. So you start out and no one knows what anyone is talking about. And then after a while, you got two people know what someone is talking about. And then a little bit further, half the team knows. And then eventually you get to a point where you kind of got a ubiquitous language for how you're talking about the application. System metaphors is a practice of saying, let's figure out how we're going to talk about this thing to start with. Let's agree on our metaphors of our language, and then we'll benefit from having ubiquitous language of this moving forward. I don't think it was necessarily the way they were doing it with extreme programming when it was first started, but behavior-driven development does a very good job of this because you've got to sit down and agree on how do I describe what we're trying to do in English. And all types of language gets hashed out as part of that so people know how to talk about the application. I'm working on a project now, and there was an interesting thing said the other day, like, hey, how's it going, Bob? How's it going with this? Like, well, I'm watching the cows. And I heard that, and I knew exactly what it meant, but I realized if anyone else heard our conversation, it would be just like, it would just seem crazy to them. And this is what Bob was actually referring to. And it wasn't Bob, but we use him as an example. So there's this program in Linux called cow say, and you can make the cow say anything you want. Well, the setup process for this team, whenever it gives you a logging message, it puts it in cow say. So you've got these messages popping up all the time of these cows going by telling you what's been installed and things like that. So within this particular team, they have this language, and if someone says they're watching the cows, everyone knows exactly what they're doing because that's the language that's developed around this. Now, it's not necessarily about the system itself, but the team's developed a language that sounds like complete craziness to anyone on the outside, but the language has developed there. So developing system metaphor says these types of things are valuable, particularly in the way we talk about the application, and we should look for ways to bring that to the left, to try to find ways of doing that sooner, like we were showing here, taking this thing that takes a long time, usually if we just let it evolve, and we say, okay, we're going to shift that to the left. You can also make it a dragon and a bunch of other things. The one I thought was really interesting, you can make it a milk carton that's telling you stuff. Sustainable pace. I'm going to move through this because I added a few slides. So oftentimes you end up with situations where you've got crazy pace over years, and then you go back and try to fix the problems that have been caused by having a crazy pace. Different way of doing it. Oh, and oftentimes you get down here and the lead developer is like, I'm out of here. This isn't worth it to my health or sanity. The best way to approach it, though, let's shift that to the left. Let's shift fixing the problem all the way to the left, and we say, okay, we start out with crazy pace. Let's fix the problem. Now we've got sustainable pace, and maybe right around here, the lead developer recruits his friend because it says this is a good environment for us to live in or to work in. And if you notice, a lot of these things, keep in mind, everything we're looking at with extreme programming is we're taking things that develop over time, or things that people have been doing, and we find ways to push them to the left. Skip to that one. Simple design, the idea of having a simple design, another practice. Oftentimes the thing that determines whether or not you have a simple design is whether or not you're able to refactor when you find a simpler way of doing it. Small releases, the value of small releases. This is, so the idea of small releases is normally you'd go all through the cycle and then you deliver something to the customer. Small release pushes that to the left again. Well, I guess pushes that to the left again, right? It says, we're going to get this through to production sooner and sooner and sooner. And that's a shift to the left. Let's see. I was talking to somebody and they had made the point that they hated software projects because they had spent 5 years, millions of dollars, and didn't have anything actually running in production. That's not an uncommon situation for people to be in. Let's see, I've covered this in some other talks, but just in brief terms, what's the value of actually trying to deliver things sooner? If I've got 4 projects that are in flight like this, let's say each of them has a value of $100,000 per year, I've got 4 things in process, I don't get any return on investment from this until after I've delivered them all. So after that, I get $400,000 of value at the end of year 2. But if I take that release and I shift it to the left, what if I do something like this? What if I finish 2 projects and now I can earn $100,000 in the first year that just wasn't there before because I was trying to do everything at the same time? These 2 down here will still be delivered at the same time, and then we'll earn the money on them in the next year. So in this case, we've now created $500,000 that just didn't exist, or $100,000 that just didn't exist before because we weren't trying to release sooner with smaller releases more frequently. And you can take that down and break it even delivering pieces of things and get even more value out of it. Smaller releases, lower risk. I'm going to skip through these slides because I've covered that. I want to make sure we've got time for stuff at the end. So extreme programming thinking is a matter of shifting things to the left. So if we think about how can we shift our quality to the left, maybe that means we're doing more tests. Actually, BDD, I think, is a great example of shifting quality to the left, right? We're going to take the behavior we expect to see, and we're going to shift it all the way to where we write that first. If we think about how to shift this to the left, we've got estimating, which a lot of people are doing. Planning game shifts that a little bit more to just in time. And then we've got the idea of creating an estimate based on the current data. Those are all ways of doing things in more and more extreme ways in order to get more value out. Something's working right. Estimates can be valuable, right? Well, the planning game says, let's try to do that in a more extreme way. What if we were to estimate just right before we were to work on it? Estimating based on current data is an even more extreme way of doing it. These, let's see. Okay, so behavior-driven development is an answer to what if we move QA all the way to the left. That's what behavior-driven development in Cucumber looks like. Okay, good. So I think we've got just about enough time. Quiz or question for you here. So this is important to me. So here's the question for you. Have you forwarded these lunch and learn invites to friends and colleagues? So true, I have shared these invites with others. False, I'm keeping these sessions a secret for myself. Or NA, I don't have any friends. And I'm sad to see we've got 7% of people in that. So go ahead and fill that out, and hopefully this will encourage you on some of the upcoming talks to forward those to friends. You should have in your inbox the Ted Lasso one that's coming up next week with Matt Phillips. Encourage you to forward that out to people. I think that's going to be a lot of fun. Matt has Every talk I've been to by Matthew Phillips has always been great. Matthew Phillips has always been very, very good. So I'm really looking forward to that talk. So encourage you to be in this category over here. So I'll give that just another minute so everybody can check on it. Go ahead and get this up here. I will post it one more time, and then we are going to do game show and give something away. So you will be competing for a copy of Starting Agile. If for some reason you've already won one of these in the past, you will be competing for my other book, which is Productivity. So it's all kinds of tips and tricks for being more productive. Everything from, did this have the way to brush your teeth? I don't think that was in here. Everything from like, is it actually worth it to organize your sock drawer? That's a good question there. And the most efficient way of parking your car in a crowded parking lot. So lots of fun things in there. So those will be your options for prizes. So let's get started here. Game time. Everybody have that? Okay, let's get started here. Okay, so click on the link. I will throw the link here one more time in case you don't have it up. Encourage you all to participate. I think we got just enough time to fit everything in. Extreme programming, you can win up to 1,000 points per answer, and the time does matter. Now, one of the interesting things about this particular, since we're using Poll Everywhere, the time does not matter as much as it does under the other, Mentimeter. Not sure exactly how it works. Okay, so is everybody ready? Can I get a thumbs up if you're ready? Oh, I do see I have a hand up. Did somebody have a question about something? 2 hands up. Okay, I think those are thumbs up. Okay. If you do have a question, throw it in the chat and I'll take a look at it. Okay, so let's go. I see lots of thumbs up. Awesome. Extreme programming was an attempt to 1, drink more water, dial good things to 11, claim to be doing testing, or implement SAFE, Scaled Agile Framework, with a random E's sticking at the end of it. So extreme programming was an attempt to drink more water, dial good things to 11, claim to be doing testing, or implement SAFE. And time's up. And yes, dial good things to 11. 65% had the right answer there. Extreme programming is saying, let's take things that are good and try to dial them all the way up to 11. And that was the thought behind a lot of what they're doing. And like I said, it wasn't a given that would actually work, right? There's lots of things that if you dial it up to 11, you will kill somebody. So these things they found worked well. There were probably some they found that didn't work so well. Okay, leaderboard. We've got lots of people with 1,000 points. We've got Alan, Astrid, Bill G, Daniel D, Darren, Hallie, Ian, Jack, John, and Kevin. Very good. Okay, test-driven development lets you write code with you can write code with a chisel, write code with a whiteboard marker, write code with chalk, write code with pencil, or write code with a light touch. How does test-driven development let you write code? And time's up. Yes, pencil. Light touch sounds very close to what we were saying, but yes, the example I gave was writing it with a pencil instead of a chisel. With the idea of you're going to write code, you get tests to prove that works, and then as you develop the rest of your application, you may come in and kind of like you were sketching and change that code and expecting it to evolve over time. Okay, leaderboard. We've narrowed it down. A few people with still perfect scores are Bill G, Daniel D, Darren, John, and Ruth. Which is a practice of extreme programming? So of these things, which is a practice of extreme programming? Are release trains, the haka, system metaphors, release on demand, or architectural runway? Which of these things is a practice of extreme programming? All right. System metaphors, that's right. System metaphors are the one that's practice of extreme. The release on demand is very important, and it's very, very close and very, very similar to the idea of doing small deliveries. The system metaphor is actually the thing that is the it is the extreme programming practice. The Haka, I think, would be great if it actually was an extreme programming practice, because it is definitely extreme, but that's not one of them, unfortunately. Although I would encourage you, if you find some of those types of things are useful in your work and you want to make it more extreme, the Haka is a very, very extreme thing to do. Lots of fun. If you have no idea what I'm talking about, you need to look up Haka, Haka. It's very interesting. Okay, we've got 1, 2, 3, 4, 5 people still at 3,000 points. Bill G, Daniel D, Darren, John, and Ruth. Next question, what practice came from doing code reviews in an extreme way? Was it the planning game, test-driven development, collective code ownership, pair programming, or lean budgets? Planning game, test-driven development, collective code ownership, pair programming, or lean budgets? And time's up. So yes, pair programming was a practice that came from doing code reviews in an extreme way. So the idea was we need to review each other's work. What happens if we review each other's code as we're actually writing the code? That became pair programming. Leaderboard. Okay, we've got Bill G, John, and Ruth still with 4,000 points, followed by, I think that's Ezekiel, DJ, Daniel D, Ralph, Yo, Astrid, and Darren. Next question. What is the most important thing to enable the ability to refactor as you go? So we discussed this. The thing that I was pointing out is being very, very key to being able to refactor as you go. Now, there's going to be a lot of good answers here. You're going to have to think back to what we actually discussed. Is it modular architecture? Is it test-driven development? Is it a good starting design? Or is it extra time in each sprint? I need to fix my capitalization on that one of those answers. What's the most important thing to enable the ability to refactor as you go? According to this talk, what we talked about. Modular architecture, test-driven development, a good starting design, or extra time in each sprint. Time's up. And yes, test-driven development. If you remember what we were talking about, the modular architecture and good design are all things that we said can be driven by test-driven development. Test-driven development forces you to create things in more modular and less coupled ways. Now, a modular design or modular architecture is very helpful in being able to refactor. The key thing we were calling out is test-driven development is one of the things that really helps you to have that capability as you go in, as you discover things. Whoops, wrong way. Okay, leaderboard. We've got John with 5,000 points in the top space, followed closely by Ezekiel, DJ, Daniel D, Ralph, Bill G, M, Ruth, Jude, and Yo. Okay, next question. Next week's talk will use examples from The A-Team, Ted Lasso, Breaking Bad, Seinfeld, or Doctor Who. So next week's talk will use examples from which of these TV shows? The A-Team, Ted Lasso, Breaking Bad, Seinfeld, or Doctor Who? And maybe I should have another question, which is who would you most like to have a talk based on what TV show? Wish it was the A-Team. Okay. Cool. Okay, Ted Lasso. Yes, 93% got it right. That's right. Ted Lasso is who will be, Matt Phillip is going to be giving us examples from. Okay, we're very, very close here. It looks like John is only ahead by, what's that work out to? A little more than, and I'm not doing the math right here. Is that going to be about 30 points, 31 points? Ezekiel, DJ, Daniel, Ralph, Bill, M, Ruth, Jude, and Yo. And I think this, can't remember if this is the last question, we've got two more. Oh, okay, so what is the URL to find videos of past talks? Throwing this in here to see if anybody remembers or if you can figure it out. What's the URL to find videos of past talks? Is it youtube.com Agile Rocks, youtube.com Agile Lunch, youtube.com Agile LNL, youtube.com Eat and Learn? And time's up. Yes, it's youtube.com Agile LNL. And you would be doing me a huge favor if you go in there and click subscribe on it. That way you get notified if there's new ones, and once I get past a certain threshold, it unlocks other things in my account. So if you want to do that, that'd be great. And leaderboard, and so the final, John is the winner here with 7,000 points, followed pretty closely by Daniel D, then Ezekiel, Ralph, DJ, Bill, M, Ruth, and Jude. So John, if you send me a screenshot and your address, I will send you whichever book you prefer, the Starting Agile or the Productivity. So just let me know and I will get one of those headed your way. Good job, John. And let's see. Last thing I want to do, there's those URLs again. Last thing I want to do, if you could give me feedback on what you liked about this talk, what would make it better, I would really, really appreciate it. That helps me a lot as I do these again. And I do go through and review these, particularly before I give the talk again. I'll go through and look at all the notes and see if I can make any tweaks to make it better. So this is my little continuous improvement loop. So thank you all for coming. Hope to see everybody next week. Matthew Phillip is going to be here. That's going to be a lot of fun. Please do take the time to fill this out. I'll paste this here again in case anybody happened to close it. Link to the book, please. So if you want the book, if you would like a copy of my book as a PDF, so that link will get you a copy of the PDF of the book, and it also puts you on the mailing list for these talks. So feel free to pull that out if you want to. Like I said, please do fill out the presentation feedback. Looks like we've got 19 underway. I've got 64 people here, so I bet we can get just a few more people to fill it out. I'm going to stare at you and tell more people that we got 20. Did that work? We'll see. Oh, the other book, the productivity book, I actually do not have a PDF of that up where we can get it. But Astrid, if you want a copy of the PDF of it, I think where I've got that. If you send me an email, I will try to find that. I've mostly used that one just as a physical book, but I probably do have the PDF. I'd be happy to send it to you. Okay, 21 underway, 23 underway. Got 58 people here. Can we get a few more to fill this out? If anything isn't relevant, but just want to know what you would like to see improved. And feel free to give me any feedback on the presentation or me as a presenter that I can use to make things better. So I appreciate that. Oh, the ISBN. Okay. If you go and look up, if you go to Amazon and look for Mark Shedd productivity, I think you'll find it, but I'll send you a link to it. John, are you offering to pass your book on to someone if somebody's wanting? Oh, you won. You won the book, right? Cool. Okay, so John's offering to give his book to someone else that's just starting Agile that might be interested in it. Look, see if he's got any takers here. Hey, Andy, text me. I'm not sure what you're seeing. Okay, I'm going to have to sign off for my next meeting. Thank you for filling these out. I see these coming in. Really appreciate it. If you haven't done it yet, here's the link. This will stay up for a few more minutes. So I really appreciate it if you fill those out. Okay, see everybody next week. Have a great rest of your week and weekend.